Okay, so let's have a look at finding the second derivative of a function. And in reality, the second derivative is just, in real sense, just the derivative of the derivative. It has some applications that we'll talk about a little bit later. But in terms of the practicalities of finding it, it's just finding this differentiate the function twice. So if we have a look at example 6, f dashed of x is simply going to be 24x cubed minus 12x squared plus 4. So the second derivative, f double dashed of x, is equal to 3/24. What's that? 72 x squared minus 24x. Okay. Something like b, we've got a product rule, two distinct functions, two distinct x's. So if we put u equal e to the x, v equals sine x, u dashed is equal to e to the x, v dash derivative of sine is cos x. So then dy dx is equal to the derivative of the first times the second function plus the derivative of the second function times the first function. So we might write that as e to the x out the front of sine x plus cos x. So now to work out the second derivative, again, two distinct functions. If I put u equal e to the x, u dashed is equal to e to the x. If I put u equal to sine x plus cos x, u dashed is equal to the derivative of sine, which is cos x, plus the derivative of cos, which is minus sine x. So then in terms of notation, d squared y dx squared is equal to the derivative of the first times the second function, cos x, plus the derivative of the second function times the first function. So if we expand everything in there, I'm going to get an e to the x sine x minus e to the x sine x, which is 0. And I'm going to get an e to the x cos x plus an e to the x cos x. I'm going to get 2 e to the x cos x as my second derivative. Okay. Keep working through. Find f dashed of 0 or f double dash. So we've got f dashed of x is equal to, a bit of a chain rule. Or not even actually. No, you could argue it is. So e to the kx is 2e to the 2x. F double dashed of x is simply going to be 4e to the 2x. So then f double dashed of 0 is 4e to the 0, which is equal to 4. Last one. If y equals, find a simple expression for dy dx and d squared y dx squared. Okay. So let's go with dy dx is equal to the derivative of cos is negative sine, so it's negative 2 sine 2x. So therefore dy dx all squared is equal to 4 sine squared 2x. Let's get the second derivative. D squared y dx squared is equal to derivative of e to the of negative 2 sine 2x. So the derivative of sine is cos, so it's going to be negative 4 cos 2x. So that squared is equal to 16 cos squared 2x. So let's substitute into our equations. Therefore, if we sub into that, I get dy dx all squared, 4 sine squared 2x plus 1/4 of the second derivative all squared, which is 16 cos squared 2x, which is 4 sine squared 2x plus 4 cos squared 2x. Take a 4 out the front. Sine squared 2x plus cos squared 2x equals 1. So we get 4.